I welcome you all to this interesting video course on deployment of Spring Boot microservices on AWS ECS. So by the end of this course, you will have the solutions or answers to all the major concerns that revolves around the deployment of the Spring Boot microservices on the cloud. So the first major concern here we have is the deployment. So once we are ready with our microservices, we will create the Docker images of them, and then we will push those Docker images to the ECR. So here ECR is Elastic Container Registry, that is a public service provided by the AWS where we can keep our images either privately or publicly. So once our images are present inside the ECR, then we will go ahead with creating the task definition in the ECS. So task definition is like a blueprint for our deployment. So in the task definition, we will refer to our image that is present in the ECR. So once the task definition is ready, we will go ahead with creating the service out of it. So that service will go ahead with creating the containers where our application will get deployed. So till here we are done with the deployment, but are we ready for the production? Not yet, right? So the next concern here we have is the service to service communication. So when we have our microservices in the local, it's very easy for us to make a service to service communication. But once our microservices are inside the containers and on the cloud, then we need to do some explicit configuration so that the service to service communication is enabled, right? So for that reason, we will go with the service connect and service discovery feature provided by the AWS on the ECS. So once our service to service communication is resolved, then next concern comes up, that is the auto scaling. So once our services are up and running, then we may expect different kinds of load. Sometimes we have a very high load, or sometimes the load is very less. So according to the load, we want our containers should get increased or should get decreased. And this can be solved using the service auto scaling feature provided by the ECS. So once we have the varying number of containers, then we need the load balancer to balance the load among these containers. So for that reason, we will implement a load balancer that will help us to balance the load among the varying number of containers. So once we are good with the load balancer, then there are some other major concerns that needs to be resolved. For example, logging, security, and rate limiting. So all these kinds of concerns cannot be solved using the load balancer. So for that reason, we need to implement the API gateway. So the API gateway will provide a single point of entry for whole of our backend microservices, along with the other concerns like logging, authentication, and rate limiting. So once we are good with this architecture, the next very important and critical concern that needs to be addressed is the security. So in this course, I will show you how to implement the highest level of security for entire our backend microservices and along with the other components. So I will throw some more light on the security in a moment. Before that, let's address the last concern we have here is the automation. So by the end of this course, you will learn how to create the end-to-end automated pipeline where once the code changes are pushed, it will automatically get built and get deployed using the pipeline. So now let's understand a bit more on the part of security. So here, if you look at the flow on the left hand side, here you can see that we will get a client request that will be received by the API gateway, and then that will be received by the load balancer that will further sends the request to our containers in the ECS, right? So this is a normal flow. But the concern here is with this implementation, every component of our service is publicly accessible. So if we create a load balancer, the load balancer will get its own DNS. So if anyone gets access to that DNS, they can directly hit the load balancer bypassing the API gateway. Similarly, the container. So every container will get an IP address. So if anyone get access to the IP address of the container, so they can directly hit the containers. So that is a major and a very high critical security concern. So this security concern can be overcome using the concepts of VPCs, subnets, route tables, and NAT gateway. So here I will in this course I will be going to explain you all these concepts, and then using those concepts we'll implement a architecture that is highly secured, where you can see now here the load balancer is in the private subnet, and all our containers as well present in the private subnet inside our VPC. So once the services are present inside the private subnet, they are not accessible to the outside world. But to make that accessible, we will create a VPC link that will help the API gateway to communicate with our private resource. And then we'll implement a NAT gateway that will help the containers to pull the images from the ECR. Here ECR and the API gateway are the public resources on the AWS which are present outside the VPC. But all the other services are present inside the VPC where our actual code is present. So right now you may not be understanding what is VPC, subnets and gateways. So we will discuss all these things in detail in this course, and we'll be at the end of this course we'll be able to deploy our services in a most secured manner. So join me in this course to learn, understand and implement all these concerns that revolves around the microservices. And these are the key takeaways from this course, and these are the list of services that we will discuss and use them to achieve our desired outcome. Let's meet inside the course.